We can move on to the next industrial paper. The speaker is Hong Tao Lin, and the paper is Bootstrapping Conditional Retrieval for User-to-Item Recommendations. The stage is yours. Thanks.
Hi everyone, I'm Hong Tao Lin from Pinterest, and I'm here to present the paper Bootstrapping Conditional Retrieval for User-to-Item Recommendations. So, as we all know, like most recommendation systems follow a multi-funnel stages where we trim down the candidates in each stages. And here we mostly care about the retrieval stages. And here's our problem statement. So we wanted to retrieve personalized items that satisfy additional conditions. As you can see on the screenshot on the right, this is a use case at Pinterest where we recommend you notifications. In a notification, we recommend you pins or items that are related to a topic. Here it's sweater patterns. So there are other use cases such as retrieve item, filter products given merchants or prices that can also fit into this case. So there are a few existing solutions for this. The most naive one is to use token-based retrieval methods where we build an inverted index using the mapping from condition to items. It's simple, it's always relevant, but there's no personalization at all. And the more popular embedding-based retrieval methods where we use a two-tile model that generate user item embeddings and serve them using approximated nearest neighbor search. In these methods, we can try to tweak that by applying a filtering technique before, during, or after the AN search to accommodate the conditional retrieval use case. So the benefit is that it's personalized and could be relevant after filtering, but the filtering itself is really inefficient in serving time. And it does not encourage the feature interaction between the user and condition when we're modeling this scenario. So this is an illustration of the very widely used two-tile models on the left and how we do approximated nearest neighbor search, such as SNSW, in production. Yeah, so our proposed method is pretty straightforward. So we simply just integrate the condition as a feature in the user side. So this condition could be encoded into embedding and then do more feature interaction with all the user features. The benefit is that it can jointly optimize for personalization and relevance. But there's one shortcoming is that this only works if there are abundant training data. Say if we are bootstrapping new use cases for a new platform or something, this may not work. So one extension to this idea is that we can reuse the same training data as the generic user-to-item retrieval, but we can use the item level attributes to generate a proxy condition as the input to user tower. So take the topic conditional retrieval, for example. At Pinterest, we have an item to topic signal, which is a one-to-many mapping. In this case, we can just basically sampling from the signal and get an approximated topic as a condition to the user side. The benefit of this approach is that it can generalize to mostly all the use cases you can think about. And in addition, we can extend this to jointly model multiple conditions in one single model to simplify the model architecture and encourage knowledge sharing. And of course, there's one single limitation that we acknowledge, which is that this method still does not guarantee 100% relevance because this is an embedding-based retrieval. So in production, we will still see if it's, we'll probably also combine this with the post-filtering technique, as I mentioned above. So yeah, let's talk about the experiment run at Pinterest. As I mentioned before, we have a new use cases that we want to recommend, a new type of notification that's surrounded by, like related to a topic. And this is a new use case, so we don't have training data given the user condition item pairs. Instead, we have existing notifications around user to item feed. So we apply the above methods and then use the topic signal to sample a condition. Here are some more details about our training methods. We use user item engagement pairs, where engagement is defined as clicks on an item or saving the item to a board. And our feature use is pretty standard for two-tier models, like user sequence, metadata, content embedding, etc. We use the inbatch inactive and sample softmax as our loss function. Here are some comparison methods we use. Index means token-based methods, where we just map a topic to all the items that can be satisfying that condition. LR means learn retrieval, essentially a two-tier model that is generic user to item retrieval, which requires a post-filtering technique to work with condition. CR is conditional retrieval, and we've tried apply like with or without post-filtering in our online experiments. So here's our experiment results. As you can see, the CR methods can outperform all the baseline that we mentioned, and applying filter or not has neutral impact on the metric we care about, such as click-through rate or weekly active users. And what's more interesting is that you can see the CR methods has only a quarter or less of the serving cost of learn retrieval with the filter. This is probably related to the better serving efficiency or filtering efficiency of the CR models. We've done offline experiment that shows without the filter, conditional retrieval can already get 80% of the topic matching rate, while learn retrieval methods only get you 20%. Finally, here are some visualizations like for the user engagement pins and the results we recommend using the token-based methods. And this is for topic around art. So as you can see, this is pretty generic art content. But if we use our methods, I've highlighted you can see the results are more relevant. As I highlighted, the orange box are all around some fruit art, and the red box around some landscape photography. So we want to highlight some future work that we don't have time to implement but are promising. One is that we can explicitly add a relevance training objective to further boost the relevance of the model. The second is to explicitly use some negatives that are under the same condition but from different users. So this can explicitly encourage the models to be personalizing the content under the same condition. Yeah, and here are some collaborators we have that made this work. And thanks for listening. Happy to answer questions.
Thanks. Thanks for the presentation. There are several questions online. I think we have time for one of them. So if you add a condition dimension to your product embedding, can you still create the KNN index in order to have fast production serving? Or do you need to have one product embedding for each potential condition?
Yeah, so did you mean for multiple conditions?
Yes.
Yeah, I think so. We can still keep one single serving index, and I guess that depends on what kind of filtering you apply for the KNN. So if you're just like using post filtering, you can still use the same serving index and then just filter the results after you get like K of them. And I've known there are some like optimizations on the serving side, constraint KNN search side that changed how they build the graph index. In that case, it's probably more efficient, but we need separate index for different conditions.
So thanks again, and I suggest you to continue the discussion online with the questions. So we can thank the speaker again.